Hello everyone. For this video, we will discuss on this question. But first, let us read the question first. Predict the product from during the electrolysis of concentrated AgBr2 by using carbon electrode. Explain your answer by showing necessary information. Draw and label the diagram. So, based on the question, we can see that the question asks us to explain the answer by showing necessary information and draw and label the diagram. Okay, but before that, let us take a look at the question. It tells us that the electrolyte used is AgBr2. And the electrode used in this question is carbon. Let's draw the diagram first. Okay, so this is the diagram we already prepared. And you have to label which one is positive terminal and which one is negative terminal, so we can determine positive terminal and negative terminal based on the battery here. And also you have to label the electrode, which is carbon solid, the electrolyte concentrated AgBr2 aqueous, and also the flows of electron from anode to cathode. And since this is electrolysis, the anode will be positive while the cathode will be negative. And also anode, the reaction occur at anode is oxidation, and the reaction occur at cathode is reduction. I think that is all for the diagram. So you guys have to label the diagram properly, and also don't forget to show its face here. Okay, that is all for this part.
Okay, for the second part, the question asks us to predict the product at both terminals. So first, we need to identify the electrolyte, which is concentrated. So the electrolyte has water, which is H2O, and also ions. For this case, we choose ions to be selectively discharged compared to water, because in concentrated electrolyte, concentration of ions is higher than water. In cases, we need to refer to this factor. So in this case, for our question, Br- is a halogen, so it is selectively discharged compared to water. But for the cation, which is Ag+, it is selectively discharged because it is more concentrated in the electrolyte compared to water. Let's take a look at our anode terminal. For the first point, Br- ion and H2O are attracted to anode. But we choose Br- ion to be selectively discharged because it has higher concentration compared to H2O. So at anode, this ion will undergo oxidation. So for our half cell equation, Br- will form Br2 gas, and we need to balance this equation by adding 2 in front of Br- and 2E at the right side of the equation to balance the charge. At cathode, Ag+ ion and H2O are attracted to cathode, but as we know, in this case, Ag+ is more concentrated than H2O, so it is selectively discharged and undergo reduction at cathode. For the half cell equation, Ag+ ion will undergo reduction, forming Ag solid, and we need to balance the equation by adding 1 electron at the left side to balance the charge. So at cathode, we can predict that silver solid is deposited, and silver the silver precipitation is silver metal. At NET, we can predict that there is formation of brown gas bubble, and we know that brown gas is bromine gas based on the half cell equation here. And we know that there is silver precipitation at the cathode terminal from this equation. That's all. Thank you.